Astronomers may have found a planet doing something that should barely happen at all, circling two failed stars from above their poles, as if the universe ignored its own blueprint. The system is called 2M1510ABB, and if the evidence holds, this may be one of the strangest real-life tattooing systems ever found. Not because it goes around two suns. We already know circumbinary planets exist. It's strange because this one seems to orbit almost perpendicular to the brown dwarf pair at its center. Not around their waist, around their poles. That sounds like a geometric detail. It isn't. In planetary formation, geometry is destiny. Our solar system looks flat for a reason. Planets usually form from a spinning disk of gas and dust, all sharing roughly the same plane. Think of pizza dough tossed into a disk. You expect the toppings to stay on the surface, not start circling straight over the crust like a helicopter. Personally, that's what makes this system so unsettling. It doesn't just look unusual. It challenges the quiet assumption that planetary systems naturally settle into familiar shapes. So what are we actually looking at? Two brown dwarfs. Objects too massive to be planets, but too small to sustain the hydrogen fusion that powers normal stars, orbiting each other in a tight eclipsing pair. Then, much farther out, a giant planet. And that planet appears to move on a path close to 90 degrees relative to the central binary plane. A cosmic side road where most models expect a traffic jam. The discovery was reported in 2024 by an international team using the European Southern Observatory's Very Large Telescope. The brown dwarf binary itself, 2-mass J15104786-281187174, usually shortened to 2M1510, sits roughly 120 light-years away. The inner pair completes an orbit in about 20.9 days, and the object inferred around them has a period of about 100 days. A giant world moving around two failed stars on an orbit that should be dynamically awkward from the moment it forms. And this is where the mystery sharpens. Because the big question isn't only, is there a planet there? It's, how did anything end up there in that orientation? If planets are born inside a disk, and disks tend to align with the central system, why would a giant planet choose the astronomical equivalent of driving sideways? One possible answer is that it didn't begin that way. Maybe the system formed in a more ordinary disk, then something torqued the orbit over time. Gravitational nudges from the binary could have slowly tilted the planet if the conditions were just right. In some theoretical work, polar circumbinary configurations can actually become stable. Stable, yes. Easy to create? Not even close. That's the difference. Nature may allow this arrangement, but it doesn't seem eager to build it often. Another possibility is even weirder. The disk itself may have become misaligned early on. Imagine a spinning vinyl record suddenly bent while the music is still playing. Around eccentric binaries, simulations have suggested that gas disks can evolve into polar orientations. If a planet formed out of that warped material, then the orbit would not be a late accident. It would be the fossil shape of a disk that refused to stay flat. Confession time. When I first read that idea, I had to stop for a second, because it means some planetary systems may inherit a kind of primordial crookedness from birth. But astronomers didn't watch this planet cross in front of the dwarfs like a neat transit. They had to infer it more indirectly. The team tracked the inner brown dwarfs with precise radial velocity measurements, watching how the pair's motion deviated from what a clean two-body orbit should produce. The outer companion leaves a gravitational fingerprint, not a photo, not a postcard, a wobble in the numbers. That matters because we are not dealing with a flashy, easy target. Brown dwarfs are dim. They sit in the blurry borderland between stars and planets. Studying them is already difficult. Finding a giant companion around an eclipsing brown dwarf binary is rarer still. And finding one that seems to be on a near-polar circumbinary orbit? That's the kind of result that makes astronomers check every assumption twice, maybe 3 times. There's a deeper reason this system hits so hard. We often talk about exoplanets as if each new discovery extends the same basic template: star, disk, planets, maybe a few oddballs around the edges. But 2M1510 suggests the edges may be much wider than the center. Our solar system may feel intuitive because we were born inside it. That does not mean it is typical. So let me ask you this. Do you think systems like ours are the cosmic norm? Or are they the exception that only feels normal because we live here? Tell me in the comments before we go one step further. There's also the Tatooine comparison. In fiction, a world with 2 suns feels exotic, but still visually tidy. The suns rise and set on the same broad horizon. This system is not tidy. If you stood on a moon of this giant planet, purely imagining here, the central brown dwarfs would trace a bizarre path in the sky, and the whole architecture would feel less like a balanced clock and more like a mobile sculpture hanging from invisible strings. Beautiful, yes, also deeply disorienting. The reason astronomers care goes beyond novelty. Extreme systems are stress tests for theory. A textbook works until nature hands you a counterexample. Then, the counterexample becomes the real lesson. In 2012, the Kepler mission confirmed the first transiting circumbinary planet, Kepler 16b, proving that planets around double star systems were not science fiction. Since then, most known circumbinary planets have looked relatively coplanar, staying close to the binary's plane. That made sense. 2M1510 doesn't. And precisely because it doesn't, it may tell us more about formation physics than a dozen ordinary systems. But there's an important caution here. Astronomers are confident about the binary. The outer companion is inferred from the data and appears planetary in mass, yet this is exactly the kind of claim that demands more observations. Science earns trust by surviving attempts to break it. The orbital solution has to keep holding up as more measurements come in. That uncertainty is not a weakness. It's the process doing its job. And what the data may be hinting at next is the part I find hardest to ignore. Because if this system is real in the way it currently appears, the strangest thing may not be the planet. It may be the message hiding behind it. Planetary systems might not converge toward neat, flat order nearly as often as we assumed. Maybe the universe is not building variations of our home over and over. Maybe it is improvising. And that changes the emotional scale of the story. This stops being one weird exoplanet and becomes a philosophical problem. How much of what we call natural is just local habit? How many invisible architectures are out there that we miss because our detection methods are biased toward flatter, simpler systems? You can feel the ground shift a little under that question. I certainly did. Take the numbers seriously for a moment. The Kepler mission found thousands of exoplanets, but only a small handful of circumbinary planets were confirmed, and most came from geometries favorable for transits. That means our catalog is not a neutral census of reality. It's a census filtered by where we happen to be standing and what our tools can easily catch. A polar circumbinary planet around brown dwarfs is almost designed to slip through the cracks, which leads to a possibility I love. 2M1510 may be weird, but it may also be weird in a way that reveals a hidden population. Not billions of these systems, maybe. I'm not claiming that. But enough to force a rewrite of what we casually picture when we hear the phrase planetary system. Flat may be common. It may not be compulsory. That's a huge difference. There's also a human scale analogy that helps. If our solar system is a well-laid dinner table, 2M1510 is a plate balanced on the chandelier. Same household, same gravity, completely different arrangement. And once you know a plate can end up there, you stop trusting the table as the universal design. If that idea just made space feel a lot less orderly than you were taught, leave a like on this video, because this single system deserves recognition for how brutally it messes with the usual picture. My own view is that discoveries like this are most valuable when they humble us, not with vague cosmic poetry, but with specifics. A binary of failed stars, an outer giant on a near polar orbit, roughly 120 light-years away. A system that probably should have been hard to build and even harder to notice. That combination is a reminder that astronomy is not just filling in a map. It is discovering that the map's basic symbols were too simple. Mini-hook. And the ending of this story is not certainty. It's something better. It's permission to think less like tourists collecting cosmic landmarks and more like detectives entering a city with hidden floors. The universe keeps producing arrangements that feel almost mischievous. 2 brown dwarfs, a giant planet, and an orbit that climbs over the poles instead of following the expected lane. If that configuration survives continued scrutiny, then 2M1510 will stand as one of those rare discoveries that doesn't just add a data point, it changes the tone of the conversation. Maybe that's the payoff. Not that we found a stranger Tatooine, but that we were reminded, again, that familiarity is not a law of physics. It's a comfort zone. And the cosmos has never shown much interest in staying inside ours. If systems like this fascinate you, the ones that make our own solar system feel less like a template and more like a lucky local arrangement, subscribe and stay with me, because out there, the next rule breaker is probably already waiting in the data.